Thank you, ma'am. I am extremely overwhelmed to get this opportunity to introduce the chief personality of a resource person today, Dr. Kasilingam Sir, Professor, Department of Managemental Studies, Pondicherry University, Pondicherry. Dr. R. Kasilingam is a professor of finance, business, analytics, and business law. He also serves as a nodal officer for RTI and public grievances of the university for the past 3.5 years. He is a multi-talented academician with MBA, CMA, ACS, ML, MCA, MPhil, and PhD qualification. He is a university rank holder and was among the toppers from the premium academic institutions. Professor Kasilingam has a blend of experience and teaching experience spanning more than 3 decades. He has more than 183 research publications with a citation index of 225, H index of 9, and I-10 index of 10. He has produced 8 PhDs, completed 2 research projects funded by NHRC and ICSSR, evaluated more than 100 PhD theses, and serves as a reviewer panel of leading international journals. He is one of the most sought of expert, a resource person by the research scholars in India and abroad in the field of data analysis. He has organized 30 plus data analysis, model building workshops, MDPs and EDPs, and also has been a resource person to 138 plus workshops, delivered a keynote address, and chaired the person in a program organized by the universities and the institute across South India. He is serving as a board of study member in the college and the university, such as MS University and TNOU, to mention a few here. He is also a member in more than half a dozen professional bodies, such as MMA, TIES, etc., and associated with TCS for academic initiatives. It's a proud for me to introduce such a great person over here who takes the rest of the session with SEM analysis using AMOS. So please, thank you.
Okay, so madam, shall I start?
Yes, sir. Yes.
Okay. So thank you, madam. Thank you for giving the opportunity. So okay. So as madam says, number of participants are very less. Okay. So including me and madam, only 20. So probably around 18, 17 people are there. So everybody can interact with me. Okay. So we will go very slowly and we will try to learn. Right. I hope. I have given the software also to madam, and I have given the material also to madam. So you can have the material. In fact, if you are interested, you can also operate. Somebody who is interested can do the operation itself, right? Okay. So now is it okay? Everybody, anybody, madam, யாராவது ஒருத்தர் இருக்காங்களா? கொஞ்சம் அதான் நாள் நான் சொல்ல அவங்க செய்யட்டும். நான் செய்யறதை விட அப்படியே பார்க்கலாம். யாராவது ஒரு ஆள் பேரை சொல்லுங்க. Anybody? யாராவது இருக்கிறீங்களா? நான் சொல்ல நீங்க செய்யலாம். You can do. ஹலோ, யார் இருக்காங்களா மேடம்?
சார் எங்க ஃபேக்கல்டிஸ் தான் இருக்காங்க, பட் அவங்களுக்கு இதுல சாஃப்ட்வேர்ஸ் இன்னும் பழகலையே சார். நீங்க அப்படியே சார், ஏன்னா நீங்க பண்ணலாம் சார்.
இருக்கிறதுல வேற யாரும் இருக்காங்களா? வேற யார் இருக்கா?
சார் புரியல சார்.
இங்க பார்ட்டிசிபென்ட்ஸ்ல கூட இருப்பாங்களா மேடம்?
பார்ட்டிசிபென்ட்ஸ் எஸ் சார். அதான் நானும் கேக்குறேன். பார்ட்டிசிபென்ட்ஸ் anyone is interested to work out with faculty சார்?
இந்த இந்து மேடம் பிஹெச்டிஆர்ல இருந்து இருக்காங்க. கல்பனா கோபால், மங்கேற்கரசி, மனோஜ் பாபு, உங்கதுல இருந்தாங்க நிறைய இருக்கிறாங்க. எம்பிஏ டிபார்ட்மெண்ட் ஜெயசியா ஒரு 4-5 பேர் உங்க ஆட்களே இருக்காங்களே. ஓகே. ஸோ வேற யாராவது பண்ணுவாங்களா, பண்ண மாட்டாங்களா
சார்? அவங்க பண்ற மாதிரி தெரியல சார்.
ஹலோ, எனிபடி? யாரும் பேச கூட மாட்டாங்களே.
மேடம், யூ கேன் கம்யூனிகேட் மேம். சார் இஸ் வெயிட்டிங்.
ஆமா, யாராவது பேசினா தான் நல்லா இருக்கும். பேசலன்னா புண்ணியப்படாதுங்க.
Yes, sir. Definitely, it will be an interactive session, sir.
ஆமா, யாராவது
But I hope everybody
ஒரு
has some
சிரி
experience.
மேடம், சிரி ஜோத்சனா மேடம் இருக்காங்களே.
Yeah, good morning, sir. Myself Jyotsna, sir, from Vijayawada.
Vijayawada, right, madam. Very good. So, very good, madam. Tell your name, madam, again.
B. Sri Jyotsna, sir.
Sri Jyotsna. Okay, very
Yes.
good, madam. Do you know SPSS, madam?
Sir, long back I worked on it. Now everything has got washed out. So I want to learn something fresh and very new. Right from scratch, I would like to learn, sir.
Okay, very good. The Sangeeta BCom? Sangeeta BCom?
Yes, yes, sir. Good morning, sir. Yes, sir.
Yeah.
Fatima College, sir.
Which college, madam?
Fatima College, Madurai, sir.
Fatima College, Madurai.
Yes, sir. Yes.
Very good. My wife has studied from that college. Okay.
Oh.
Okay, very good.
So happy, sir.
So,
Yeah.
okay.
Thank
So
you.
now, can you do with me, madam? Sangeeta, madam?
Sir, I know SPSS little, but I'm in between. I have to move to college, so continuously not able to be in this thing, sir. It will take 20 minutes to reach my college. So அந்த மாதிரி டைம் பார்த்து தான் நான் உட்கார்ந்து இருக்கேன். அதான் எனக்கு நடுவுல
இல்ல காலேஜ்ல இல்லையா? நடுவுல இருக்கா ரோட்ல?
இல்ல வீட்ல இருக்கேன் சார். எனக்கு காலேஜ் வந்து 12 o'clock தான்.
ஓகே ஓகே ஓகே.
ஓ, அதனால இன் பிட்வீன் ஒரு செஷன் நடுவுல நான் ஒரு 15 மினிட்ஸ் டிராவல் பண்ணி ஏர்பாட் மாட்டிட்டு அப்படியே டிரைவ் பண்ணிட்டு கேட்டுக்கிட்டே போயிடலாம் அப்படின்னு நினைச்சு நான் இருக்கேன். எனக்கு கொஞ்சம் ப்ராப்ளம் இருக்கு. நாளையில இருந்து வேணா நான் வேணா AMOS I don't know sir, but SPSS கொஞ்சம் தெரியும் எனக்கு.
சரி, ஓகே. Okay, Sangeeta madam, that is the Gayatri Govindaraj Maladi. Gayatri madam. Hello.
Sir, good morning, sir.
என்ன நீங்க ஸ்டூடெண்டா இல்ல வாத்தியாரா?
இல்ல சார், நான் ஸ்டூடெண்ட் தான் சார். இப்பதான் சார் 1 month ஆச்சு. ரிசர்ச் ஸ்காலர் சார். ஆமாங்க சார்.
ஸ்டூடெண்ட் ரிசர்ச் ஸ்காலர், ரைட்.
ஆமாங்க சார்.
ஓகே 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 மேடம். கோவிந்தராஜ் மாலதி எப்படி? கோவிந்தராஜ் மாலதி, கோவிந்தராஜ் மாலதி.
All participants are requested to introduce yourself, please.
இல்ல வேண்டாம், இன்ட்ரோடியூஸ்லாம் வேண்டாம் மேடம், இன்ட்ரோடியூஸ்லாம் வேண்டாம்.
இல்ல அவங்க பிஸியா இருப்பாங்கல்ல அதனால.
யாராவது ஒருத்தர் இன்டராக்ட் பண்ணாங்கன்னா நான் சொல்ற மாதிரி இருக்கும், இல்லைன்னா ஒன்றும் புரியாது மேடம். ஓகே, அது மாதிரி அதுக்காகத்தான் யாராவது ஒருத்தரை பார்க்குறேன். ஐ எம் சர்ச்சிங் ஃபார் ஒன் பர்சன், ரைட். கோவிந்தராஜ் மாலதி, she is a student or a faculty or a research scholar? கோவிந்தராஜ் மாலதி. Okay, so she is not ready to talk also. Very good. So Indu madam, எத்தனை வருஷம் ஆச்சு? ஜாயின் பண்ணிருக்கீங்க. ஓகே, வெரி குட். சரி, ஓகே, வரட்டும். மங்கையர்கரசி மேடம், மங்கையர்கரசி மேடம். ஹலோ மங்கையர்கரசி மேடம், மங்கையர்கரசி. ஓகே.
Hello sir, morning sir.
முத்து கணேஸ்வரியா?
Yes sir.
ஓகே, முத்து
Sir,
கணேஸ்வரி.
I am a research scholar sir.
For research scholar where madam?
Ainada Janamal College, Sivagasi sir.
Very good. எந்த டிபார்ட்மெண்ட்?
Commerce ma'am, commerce sir.
செல்வகுமார் சார் இருக்காரு, அதுவா?
Yes sir, yes sir.
சோனப்பிரியாவா? உங்க பேர் என்ன?
Swarnapriya ma'am.
Swarnapriya. Very good.
Yes ma'am. Yes sir.
Very good. எத்தனை வருஷம் ஆச்சு சேர்ந்து?
Sir, 4 months sir.
விக்னேஸ்வரனா அவர் பேர் என்ன? ஒரு பையன் இருப்பானே, நல்ல பையன். ப்ராஜெக்ட் காளீஸ்வரன் நம்ம தீவிர விசுவாசி அந்த பையன்.
ஆமா சார். Yes sir.
சரி, வெரி குட்.
Now he submitted sir.
Okay, so now I'm the college.
Sir, PSR engineering, PSR arts and science college, sir.
Eduma?
PSR arts and science college, sir. He works at.
Oh, appliya.
Sir.
Sure, okay, we will start. Okay, now the AMOS, that is the task given to me. So which consists of two things. One is the CFA, otherwise called measurement model. CFA means confirmatory factor analysis. You have to write, everybody, right? Don't think that they are giving the audio, video. Please do not depend upon video, right? Please interact with me, learn now itself. Some people will think video are giving, we will learn later. That will not work. Okay, when I am teaching, you have to learn, right? So you interact with me, talk to me, otherwise no use. Okay, so you might think with some meaning, but when you are telling, that thing may not be right. So I will demonstrate how. Please please interact with me, right? Okay, so now the sum, otherwise we call it as the AMOS. We have other software like Smart PLS, Literal, and M+. Okay, so like this, there are many softwares. So these softwares, we use it for two purposes. Purpose one, measurement model, otherwise called as CFA. CFA means confirmatory factor analysis, right? So that is more or less similar to factor analysis, right? So how it is different, that I will tell, but that I will tell little later. Then another model is a path analysis, otherwise structural model, otherwise a path analysis, otherwise a structural model. That is similar to regression. Right? So first we will start with the structural model, right? Otherwise we will start with the regression. I will introduce regression. I will try to teach regression. Please try to learn, try to write, try to talk to me. All right. So first I'm going to talk about the regression, right? So why I am going to talk about regression? This path analysis is ditto of regression, nothing new. Okay, all interpretation, all meaning are similar to regression only. Only thing is we will be using some new concepts, that's all. But the interpretation is very, very, very same. Nothing new at all. So I will tell what is regression first, right? So anybody, do you have knowledge about regression? Anybody? Some knowledge? Anybody? Hello, anybody?
Sir, regression we use for one dependent variable and more than one independent variable, sir.
Okay, so you know some knowledge about regression, right? Okay, so now the regression is when we will use is point number one. See, normally all high square, ANOVA, or any variable, we will use two variables. We will have minimum two variables, right? Minimum two variables we will have. So here we will have two variables minimum. So where we will call one variable as a dependent variable and another variable called independent variable, right? So we will say one variable is a dependent variable, another variable as a independent variable, right? Anything new? Anything more? Right? We will have two variables. One is an independent variable, another is a dependent variable. Anything more? Quickly.
It should have an influence on the other variable. First variable should have an influence on the other variable, or impact.
Okay. So you are telling the word right, madam, but you are having wrong. That is why you have to talk. So now the purpose of regression is to find out the influence of one variable on the another variable, right? So the purpose of regression is to find out the influence of one variable on the another variable. So the variable which influence, we call it as independent variable. The variable which is influenced, we call it as a dependent variable, right? So the dependent variable is depending on, that is the meaning. That is why dependent. So dependent variable is depending on, right? So independent variable. So two variable, right? The madam, she said, right? Two variable, one variable independent, another variable dependent, right? So the purpose of recursion is used to find out the influence of one variable on the another variable. Otherwise, more precisely, influence of independent variable on the dependent variable. Right, very good. Next. Anything else? Okay, very good. Now I will go to my discussion. What I see, everybody should open the mouth, right? Don't simply keep quiet. Okay, so everybody should talk something. Otherwise, I will call also. Everybody should talk one word or other. Okay, you have to repeat at least what I am telling. So simply coming, going, no use. Eh? Even if you learn 5 points, sufficient. Okay, so you need not learn many things. Okay, so now what you see here? Oh, I'm not present at all, sorry. First, let me present. Right. So now what you see, madam? Anybody? Somebody please tell what you see.
Sir, not yet shared, sir.
Questioner, sir.
The screen is not.
Questioner.
Questionnaire.
Sir, questionnaire, sir.
Okay, so it is simple questionnaire, right? It is simple questionnaire. So please go through question number 2 and question number 3. So question number 2 is, are you happy with this organization? Okay, so where we are trying to measure the happiness. Third question is, how committed are you to a long-term service at Sheraton Park? So this is a questionnaire. We want to measure their commitment. So one is we want to measure their happiness, and another question is we want to measure their commitment, right? So both we have used 5-point scale, right? So now, so okay, so now I have this questionnaire. Let's see. So now, what you see now? What do you see now?
Data variable, sir. Data, sir. Data view.
Data, right? Otherwise, whatever data collected for the 4 questions, it is ended here. It is this one, right? So now, immediately after answering, please mute. You have to be very active. Unmute, mute, unmute, mute, right? So please do not. Okay. So immediately, please mute, right? So now, so from this we can understand we have collected 100 samples, right? So we have collected 100 samples, right? Okay. So now I'm going to use question number 2 and question number 3, right? The happiness and commitment. I'm going to use regression now, right? So first of all, can I use the regression? Yes, I can use the regression because for both questions are taken at a 5-point scale. Once the questions are taken at 5-point scale, that is considered as metric variable. So for a regression, please understand. For a regression, please understand. You have to put only the metric variable, right? So you should not use the categorical variable like age, gender, education, qualification. All these things you are not supposed to use, right? You are not supposed to use in regression. Many theses I have seen, but people are using. At least people have listened to this one. Please do not use. Please do not use. I can demonstrate how it is wrong. I can demonstrate how it is wrong, but that is not my purpose today. So now what I am trying to tell, education, age, gender, right? So probably all demographic variable do not use for regression, right? Very good. So now it is a 5-point scale.
So sorry to interrupt, sir.
Yes, madam.
Even when we are performing this factor analysis and all, we use this multiple regression analysis, after which we go for this basic grouping and all. Even there, we are not supposed to use this education, age, and gender also.
No, I don't understand your question, madam.
Totally for regressionக்கு வந்து இந்த education age எந்த nominal variable நம்ம எடுக்க கூடாது. இந்த ஆன்சர் நீங்க சொல்லுங்க.
ஆமா, கரெக்ட்.
ஓகே சார்.
ஆமா, அதோட நுப்பாட்டிக்கிறீங்க. அடுத்ததை கேட்டீங்கன்னா நீங்க குழம்பிடுவீங்க. அடுத்தது நம்ம பேசலாம், பட் இப்போ தெளிவா இருக்கிறது என்னன்னா, ஓகே, நீங்க அந்த ஃபேக்டர்ல என்ன போடுவோம் அதெல்லாம் சொல்ல ட்ரை பண்றீங்க. அதெல்லாம் இப்போ போட்டு குழப்ப வேண்டாம். இப்போ என்ன கத்துக்கிறோமோ அதை மட்டும் கத்துக்கிறீங்க, ரைட்டா? அதை மட்டும். அதுல ஏதாவது டவுட் இருந்துச்சுன்னா நீங்க கேளுங்க, ரைட்டா? எனக்கு எல்லாத்தையும் சொல்ல தெரியும், அது ஒன்றும் பிரச்சனை இல்லை. பட் குழம்பிடுவோம், அட்டென்ஷன் அங்கிட்டு போயிடும். சரியா? Very good. So now I got 2 metric variable, happiness and commitment. I can perform regression. Now before performing regression, you need to know which is dependent, because 2 variables, one is a dependent, another is a independent. Now you need to know which is dependent, which is independent. Yeah, tell me which is dependent, which is independent.
Variable which influence other is dependent. Other.
No, I am not asking theory, madam. In this situation, I am asking. Now the situation is given. When the situation is given, why do you give the theory? Now here, cover the case.
Okay, sir.
Yeah, tell me.
Happiness.
Sir, happiness dependent and commitment independent.
Happiness
Dependent, commitment independent.
Okay. So
Happiness depends on commitment.
okay. So you are faculty, madam?
Yes, sir.
Okay. Are you a marketing faculty?
No, sir. HR, sir. HR, sir.
HR also we are studying satisfaction and commitment, but you are making a very wrong statement, madam. Okay. Now anybody else? Anybody else?
No, sir.
என்ன நோவா? Anybody else நோன்னா எனக்கு புரியல. Hello? Hello? Okay. So now commitment is the dependent variable, happiness is the independent variable, right? How to identify? we need to have theory, we need to have logic, right? Commitment, only people are happy, okay, commitment will come, that is the logic. And okay, so that is here in HR, in marketing. Okay, so we have, okay, customer satisfaction is not our objective. Customer delight is our objective, which means customer loyalty is our objective. So customer loyalty is ultimate than the customer satisfaction, right? So the loyalty, commitment, that is the dependent variable, and happiness or satisfaction is the independent variable. Okay, now, okay, there are many ways to identify, but look at the theory and some logic and the existing literature. Okay, now I am going to perform. Anybody, can you tell me where I have to go, how to perform? If you know, please tell me.
Analyze,
Analyze,
linear,
Regression,
regression,
linear,
linear.
dependent,
Commitment in the
committed
commitment in
under
the dependent.
committed. I have to click like
and
this. I have to use this arrow. Please watch carefully. Happiness, I have to click like
under
this.
independent.
Is it okay now?
Yes, sir.
Okay. Okay. Now let me say okay. Okay. So now we have three output. One is model summary output and ANOVA output and the coefficient output. Now, see, normally I will take 2 hours for this regression alone. Okay, so I can demonstrate how each values are coming. All values I can calculate and tell. But that is not my objective today. Okay, now, okay, so whatever required, minimum requirement I am going to tell. Minimum requirement to write interpretation in the thesis. First of all, what is our objective of regression? What is the objective of regression? Somebody please tell me.
To know the relationship between variables.
To know how one variable influences the other variable.
Okay. So not a relation, madam. Not a relation. We can tell relation also. We can tell the relation also. Right. But the appropriate word is influence.
Influence.
So to find out the influence of here, what is my objective? Here in this case, what is my objective? Here, here a case. Now I have a case now, right? Here, what is my objective? Why I have performed regression?
How commitment influences the happiness. To know how commitment influences the happiness. Here, to know how far commitment plays a main role in influencing the happiness.
Please, that is why you have to listen carefully. You have to listen carefully, madam. You are giving
Okay, sir.
answer. So now I have told you the purpose of regression is to find out the influence of independent variable on the dependent variable. Clear?
Okay, sir. Yeah. Okay, sir. Yes, sir. Yes, sir. I just changed the variable. Okay, yes, sir. Understood, sir.
Yeah, tell me. Hello?
Sir?
Why are here?
Tell about the objective, sir.
No. Why I am performing regression, right, madam? Why I am performing regression, madam? Here now to find out.
To find out how happiness influences the the commitment.
Okay. So here not how. Okay, I want to find out the influence of happiness on the commitment. Otherwise, I want to find out whether happiness is influencing the commitment. Commitment is the dependent variable, right? My independent variable is happiness. You have to write. Please write down. Okay. So this is the very basic I am telling. I want to find out the influence, whether happiness influence the commitment or not. That is my objective. Okay. Okay. Now, that is my question. That is the question before me. Now, I need to give an answer. Now, because I have performed the regression, now I have a result. I should give an answer to that question. Okay. So, for some purpose, I have done. Now, I have performed. Now, I have a result. Now, I have to tell whether it is influencing or not. So, now how to find out? Now, look at this significant value. Look at this significant value. So, straight to happiness. Here, this is the happiness. This is the significant value. Now, what is the significant value? What is the significant value?
0.00.
0.00030. It will do 3 decimals. Right. Now, I am going to give inference. Please listen. If the significant value is less than 0.05, if the significant value is less than 0.05, then reject the null hypothesis. Right. You are written. Now, my purpose is to find out, I need to know what is null hypothesis. Now, let me frame null hypothesis. When my purpose is to find out whether the happiness influencing the commitment or not, my null hypothesis is happiness is not influencing the commitment. There is no influence. Otherwise, happiness is not influencing the commitment. Okay, now I hope you are clear. Null hypothesis. When my purpose is to find out whether it influences, so null hypothesis, there is no influence. So independent variable happiness is not influencing the dependent variable commitment. Right. So now that is rejected. When it is less than 0.05, that is rejected. So null hypothesis rejected, which means no influence is rejected, which means alternate hypothesis accepted, which means what is alternate hypothesis? There is an influence. So there is an influence of happiness on commitment, or happiness is influencing the commitment. Clear? Hello, is it okay?
Yes,
sir.
Yes, sir.
Now, okay. Now I will tell you in another simple form. First of all, if the significant value is less than 0.05, null hypothesis rejected. What is null hypothesis? No influence. No influence is rejected, which means there is an influence. Okay, so that is one way. That is the right way. But okay, but every time you need not write null hypothesis, you need not write this many way. Straight away, by looking at the significant value, okay, Finally, what we have concluded? Happiness is influencing the commitment. That is what we have concluded. Now straight away we can go to the conclusion. How? If the significant value is less than 0.05, which means there is an influence. Let me tell again. If the significant value is less than 0.05, which means there is an influence. Right? Somebody please tell what I have stated. Please tell.
If the significant value is less than 0.05, there is an influence.
Okay, so independent variable is influencing
Influence
the
dependent variable.
Correct? Clear now?
Yes, sir.
Yes, sir.
Confuse me later. Right? I think you will not confuse me later. Hello?
Yes, sir. Sure. Yes, sir. Sure.
Very good. Very good. So now that is the first point, right? Looking at this one, if this value is 0.00, which means this independent variable influencing the dependent variable. Right? Very good. Now, right? Let me tell the regression equation. Regression equation is y equal to a plus bx. My regression equation is y is equal to a plus bx. I think you are right. See, I am giving a break because you have to write down, right? That is why I am giving a break. So my regression equation is okay, y equal to a plus bx. That is my regression equation, where a is called intercept, b is called beta or regression coefficient. Okay, so now write down the regression equation. Somebody please write down the regression equation. Y equal to a plus bx, right? That is the general equation. Now, based on this result, please write down the equation. Somebody write and tell, and then I will tell. Hello? Written or not written?
Written, sir.
Read, madam.
Y is equal to a plus bx.
That I have shown, madam. So what is A, what is B? Write down by using A and B. Right.
1.578 plus.
Okay, now we have a specific case, which means we have to use this one. Yeah, now tell me.
1.578 plus 0.592 into x.
Okay, so y is equal to A is 1.578, B is 0.592. So y is equal to 1.578 plus 0.592 into x. Now what is x, what is y? Use that also. What is y?
Commitment.
Dependent
variable.
Y is a dependent variable. So here our dependent variable is commitment. So commitment equal to 1.578 plus 0.592 into happiness. Right. So now regression, we call it as a estimation technique or prediction technique or forecasting technique. Why? Because now when you know this equation, commitment equal to 1.578 plus 0.592 into satisfaction. If you know your commitment satisfaction, then can we predict commitment? Hello?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So that is why independent variable is variable available to you. So only our idea is predicting the commitment, predicting the performance, predicting the sales. So when we know what is the advertising expenses, we can predict the sales. Sales is a dependent variable. Advertising expenses, it is your known variable. Now when you advertise this much, how much sales you will get? So regression is a prediction technique. We can predict dependent variable. So dependent variable is our most important variable. That is what we want to achieve. So we want to know we want to achieve that performance. We want to achieve the sales. We want to score more marks. So what we have to do? So we need to know what are all the influencing variables, so that we will do all these things, so that we will improve the performance. Clear?
Yes,
Clear?
sir.
Right. So now you need to write the equation also. You need to write the equation also. So that is the point number 2. Right. First you need to tell what is whether it is influencing or not. Second one is, once it is influencing, you can write the equation. That is the point number 2. Next, we have the t value, right? We have the t value. Now we have the t value. Now I am going to tell the use of this t value. Right. So now look at this slide. Try to understand something. Hello?
Yes, sir. Yes, sir.
Right. What you understood? You have to tell 2 points. Point number 1. When the significant value is 0.05, the corresponding t value is 1.96. Am I right?
Yes, sir.
Okay. So when for a significant value of 0.05, my corresponding t value is 1.96. Right. That is the point number 1. Right. Point number 2.
Confidence level is also increasing, sir.
Yes. Yes, madam.
The confidence level, sir.
That is fine. But by comparing the significant value and t value, you have to tell something.
As the significant value goes down, your t value gets increased, sir. That is the concept.
Yes, sir.
Okay.
T value. Yes,
Now
sir.
wait. When the significant value is decreasing, t value is increasing.
Yes, sir.
Okay. Otherwise, okay. So the t value is result in significant value. Okay. So when the t value increases, significant value will come down. Right.
Yes, sir.
So at the 5% level, it is 1.96. Now, okay. So now you know 2 points. I have given 2 points. Now You have to tell, okay, so now without looking into the significant value, by looking at the t value, I want to find out whether the happiness influencing commitment or not. I want to look at the t value. I want to tell whether the happiness is influencing commitment or not. Please tell me how.
T value is increasing, sir.
Yes? How to find out? Please tell me. Now let us presume that I do not have significant value. I got t value alone.
T value is more than, yes, sir. Definitely it is influencing.
Yes, madam?
3.0. T value is 5.003. T value is
more than 1.96.
So,
Tell again. Madam, you are right. Tell.
Sir, our T value is 5.003, sir. It was more than 0.96, sir. So, our increasing the commit finance is increasing the.
We can also say it is more than 2.58.
No, madam, that is fine. That is fine. Okay, but we are not looking at many things. I have told you 2 points. For a significant value of 0.05, t value is 1.96. Right. When the significant value is decreasing, t value is increasing. Now, this is the two things we have learned. By looking at the two things, you have to tell without looking at the significant value. By looking at the t value, I should come to inference. How? Right. Let me tell you. When the t value is more than 1.6, clear? Hello?
Sir, sound is breaking.
So others, immediately please mute here. So don't look at to us. When you are listening, please listen. Right. So now clear. See, now let me tell again. When the t value is more than 1.96, which means there is an influence. Can I tell or not? Hello?
Yes, sir.
Yeah, very simple, right? So
Yes.
yeah, now okay, that is what we have compared. Okay, so when the significant value is less than 0.05, there is an influence, or when the t value is more than 1.96, there is an influence. So now we have learned one more by looking at the t value, right? Very good. Now this is over. So now we have to write the inference for the beta value. Now beta value is 0.592. What is the meaning of that beta value 0.592? What is the meaning of beta value 0.592? Anybody? Okay. So now I will demonstrate how it is. So now look at okay. Look at the equation. Y is equal to a plus bx. That is the equation. Suppose beta is 2, b is 2, a is 5. Let us assume all the values, right? A is 5, b is 2. Right. Now, so how will you write? How will you write? Y equal
5
to
plus 2
5 plus 2 into x, right? Yeah, okay. Is it okay? So, okay. Now, suppose equal to 5 plus 2. Okay, 2 into x. So suppose x is 10, what happens? X is 10, what happens?
5 plus 2 into 10, sir.
5 plus 2 into 10. Then what is the value?
25, sir.
25.
Okay. Okay. So now suppose now you please write down these cases. A is equal to 5, B is equal to 2, then Y is equal to 5 plus 2 into X. Right. Now X we assume it is 10, then Y is equal to 5 plus 2 into 10, which is equal to 25. Now let me increase X by 1. Right, which means X is equal to 11. X is equal to 11. Then Y equal to
5 plus 2 into 27.
yeah?
5 plus 2 into 11.
How much?
27, sir.
27.
27.
Y is equal
Right.
to 27.
Okay. Now, when X is increasing by 1, Y is increasing by
2, sir.
2. Why? Because beta is 2. Beta is 2. B is 2. Beta is 2. So what is the meaning of beta? When beta is 2, the meaning is when there is a 1 unit increase in X, so beta is when there is a 1 unit increase in S, what is the increase in Y? So here in this case, right. So now somebody write inference for this 0.592. Now in this case, hello. So now when there is a 1 unit is increase in X, so what is the unit increase in Y? That is the beta. Now in this case, somebody please tell.
When there is 1 unit increase in X, there is 0.592 increase in Y.
Okay. So now here this is a case, madam. This is a case. Case means we have variables. Yeah. You cannot tell in general. You have to tell specifically. Yeah. Now tell. When there is a
1 unit increase in commitment, there is an increase in happiness. There is 1 unit happiness. There is 0.592 increase in commitment.
When there is a 1 unit increase in happiness, there is a 0.592 increase in commitment. Okay, so this independent variable, all these things do not confuse, madam. X is the independent variable here, happiness. Very good. So now we have learned this table, right? We need to look at some more this one now. Now let me go to the R square. Let me go to the R square, right? R square. Okay. So the R square value is 0.336. So R square is degree of determination. R square is degree of determination. R square is degree of determination. So what is the meaning of R square? Degree of determination. Okay. So which means here we are determining commitment. Right? We are predicting the commitment. Yes or no? We are determining the commitment. So what is the degree of we are determining commitment? So now we can determine the commitment. Okay, otherwise I will tell. See, 33.6% of commitment. 33.6% of commitment can be determined with the help of so now see, let me okay, please understand this one carefully. So my R square is 0.336, otherwise 33.6%. So this is R square, degree of determination. So I can determine commitment or 33.6% of commitment can be measured with the help of satisfaction. So 33.6% of commitment is depending on this satisfaction. So how much of commitment is depending on this one? So how much of commitment can be determined with the help of this variable? That is the R square. What extent we can determine. So otherwise we can tell the degree of changes in we are trying to determine changes, right? Changes in commitment. So 33.6% of changes in commitment is due to changes in satisfaction. So 33.6% of variability in commitment can be determined with the help of satisfaction or happiness. Hello? Is it okay?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Now, fine. Now, okay. Now, okay. So now we will come to the next one. Next one is the ANOVA table, right? ANOVA table, right? See, when the ANOVA table is significant, which means, okay, we are significantly predicting the commitment with the help of the happiness. Otherwise, the model is fit. Model is fit, you can tell. See, this is a model. Whenever you write equation, that is the model. The model is fit. That is the point number one. Otherwise, you can tell we are sufficiently predicting commitment with the help of happiness. Our prediction is sufficient. We are sufficiently predicting. Though it is 33.6%, but that itself sufficient. We are sufficiently predicting. Okay, so our model is sufficiently predicting the happiness at commitment. Okay, so the prediction is fine. So now people used to tell the R square is above. We are predicting only 33%. That is sufficient. That is what it says. So people might tell R square should be more than 0.5, more than 0.6, all these things. That is not sufficient. That is not necessary. When the ANOVA table is significant, which means we are significantly predicting, that is sufficiently predicting. Now, see what is this one? What is this one? That is sufficient. Whatever I have told you is sufficient. But what is this? Let me try to explain. So now regression is prediction. Regressed, predict. Residual is what is not predicted. Regression is predicted. Residual is what is not predicted. So total is addition of predicted, not predicted, total. Now this sum of square divided by degrees of freedom is mean sum of square. Residual divided by degrees of freedom is this one. Right. Now what is F? Now what is F? F is this divided by this. 21.745 divided by 0.439. Okay, so that is F is mean sum of square of regression divided by mean square of residual, mean average, okay, divided by this one, degrees. So the regression divided by residual, that is F. 21 divided by 0.4 is F. So now let me tell again, regression divided by residual. So regression is 21, this is 0.5, so here it is 49. So what we can tell is, okay, the prediction, this is not prediction, prediction is 49 times, prediction is 49 times more than what is not predicted. Prediction, regression is 49 times more than what is not predicted. So 49. So which means it is sufficient. What is prediction is 49 times more than the what is not predicted. If it is 4 times itself, it is sufficient, but we are getting 49 times, so definitely it is sufficient. Is it okay? Hello?
Yes, sir.
Okay. So now I have to tell one thing more, that is the standardized beta. Okay. So now I will show one more data. You have to tell me. Huh? Okay. Everybody, I think everybody should have understood. I'm telling in a very, very slow way, not running. Now what you see?
Data set of income and savings, sir.
Data set for income and saving. We have two variables, total income, total monthly saving. Okay, so total income and total savings. Now, so first condition, both are metric variable. Okay, because actual values are there, so it is a metric variable. I can perform regression, right? So now from these two variables, which is dependent, which is independent. Which is dependent, which is independent.
Saving is dependent on how much you earn, sir.
Okay. Saving is a dependent variable. Income is a independent variable. Saving is a function of income. Saving is depending on income. Right. So now how to perform? Tell somebody.
Analyze,
Analyze,
regression,
regression,
linear,
linear.
savings is a dependent variable. Dependent, income is independent, under independent. Let's put okay.
Okay. Tell one by one. But tell one by one.
Y is equal to A plus BX, sir. That value is.
Madam. No, wait, madam. So first, you cannot jump, madam.
First, objectives to find out whether the income influence the savings.
No, that objective and all you need not tell. Now result is there.
Significant
Hypothesis.
Less than 0.0. So we reject null hypothesis. That is, there's an influence on, right, sir?
Yeah, proceed. Now we have result. Now tell me. Somebody tell. Arey, we have already told you. Everybody please open the mouth. Okay, no one should keep quiet.
Significant value is less than 0.0005. Sorry. That means result is income influence savings.
Okay, very good. Okay, very simple. Significant value is 0.00, which is
Less than 0.05.
Which means total influencing the total savings. Very good. That's all. Next, that is the first thing you have to write. Next. Next.
Alternatively, t value is more than 1.96. அது சொல்லலாமா சார்?
சொல்லுங்க ஒன்றும் பிரச்சனை இல்லை. நம்ம எப்படி சொல்லுவோம்னா ரெண்டையும் தனித்தனி சொல்றதுல டி வேல்யூ எவ்வளவு, சிக்னிபிகன்ட் வேல்யூ எவ்வளவு, இப்படி இருக்கிறதுனால there is an influence. ரெண்டையும் ஒரே ஸ்ட்ரோக்ல போட்டு சொல்லிடுவோம். ரெண்டு ஒரே ரிசல்ட் தானே தரப்போகுது. ரெண்டு வெவ்வேறு ரிசல்ட். அதனால ரெண்டையும் அடுத்தடுத்து கமா போட்டு எடுத்துட்டு ஓகே. ஸோ அப்புறம் நெக்ஸ்ட்
beta influence answer.
Yes, madam. Next. You can write. You have to write the equation. Next, you have to write the equation. Write the equation. Somebody write the equation.
3,281.033 plus 0.161 into x, sir.
Okay. So now here it is a specific case, madam. You are right, but substitute x and y also. Substitute what is x and what is y.
X is an independent variable. Income.
Tell equation with x instead of x.
Yeah. Income is equal to
Income equal to
Savings.
Savings is equal to
Savings is equal to
savings is equal
savings
to
is equal to
3,281.033 plus 0.161 of income.
So now savings, total savings is equal to 3,281 plus 0.161 into income. Clear?
Yes,
Okay,
sir.
you have to tell
Yes, sir.
nothing you cannot learn. Yeah, right. So now somebody should tell R square. Yeah, R square.
16.3% of savings can be determined with the help of income.
Okay, so the 16.3% of variability in savings can be determined with the help of total income. Okay, so the 16.3% of changes in savings can be determined with the help of income. Right. So now we have ANOVA table. What is the meaning of ANOVA table? What is the meaning of ANOVA table?
Sir, ANOVA is significant, sir. We can calculate the F value by using the mean square. That is.
Yeah, that and all I have taught you, madam. That is not necessary. See, in the
Okay,
thesis,
sir.
you cannot write all these things, right?
Mean
Significantly
square.
predicting the savings with the help of income, sir. So the significance of ANOVA helps to.
What is the significant value? Here, ANOVA is less than
Less than
0.0.
0.00.
Which means we are significantly predicting the changes in saving with the help of changes in income. So we are significantly predicting. We are significantly predicting the changes in income, changes in saving with the help of income. We are significantly predicting. The model is fit. We are sufficiently predicting the changes in savings. Okay, changes in saving. Always you have to use the dependent variable. Now clear?
Yes, sir.
Okay, so now I'm going to tell one more which is also important. Okay, also important. Carefully, okay, carefully listen. Okay, so now analyze old example I'm using. Regression. Okay, so linear, commitment, happiness. Okay, I'm performing. I'm going to the result. I'm going to the result. Now, right. Now I'm going to tell this standardized beta. Now I'm going to tell how I'm getting this standardized beta of 0.580. Standardized beta of 0.580. Okay. So now right, 0.580. Very good. So now please you have to notice the result. So this is 0.592, this is 0.580. This Unstandardized beta is 0.592. This is 0.580. Right. Okay. Very good. Now, okay, what I'm going to do is analyze descriptive statistics, descriptives. I'm going to put happiness and commitment both. Descriptive statistics, descriptives. I'm using both happiness and commitment. Save the standardized value as variable. Okay, save standardized value as variable. Okay, so now if I go and see there, now I have two new values. Earlier I had this 4, now I am having two new values. Because standardized variable, I have asked it to save as a variable. So it has taken as a variable, it is here. So which means these two are standardized value. Happiness, this is that happy, is the standardized value of happiness. Is it committed is the standardized value of committed. Otherwise it is called Z score. Otherwise it is called Z score. So how the Z score is calculated? Z score is calculated Z equal to X minus X bar divided by sigma. X minus X bar divided by sigma. Here, happiness, find out the mean value, right? Okay, mean value. Okay, so this is the X value, X3 minus mean. What is the mean? Okay, divided by what is the standard deviation. So if you put, you will get this value. So next one like that, 4 minus that mean value divided by standard deviation, this value. Okay. So no. Okay. Now we have standardized values. Now I'm going to run a regression. Analyze regression linear okay, I'm going to use these two. Z committed, not original value, standardized value now. Z committed, Z happiness. Now let me say okay. So I have standardized the value, I have put it, then I'm using regression for that. Now look at the beta. Beta is 0.580. You can see the beta point. So standardized, now this beta and this beta, right? Earlier if you see, okay, so earlier standardized beta is 0.580. Now regular beta itself 0.580. Now the standardized beta means when the values are standardized. When the values are standardized, then when you run a regression, okay, whatever you get is a standardized beta. So standardized beta is nothing but when the values are standardized, then when we run, we will get some beta that is called the standardized beta. Okay. Now, okay, so now there are some specific purpose for standardized beta. Now, I will tell the specific purpose of standardized. Okay, so now I have many variables. I am going to run multiple regression where I am going to take the regression dependent variable gold price. Okay, so all other variables are independent variables. So this is called multiple regression. When you put only one independent variable, that is a simple regression. Now it is a multiple regression. Now you will have a standardized beta. Now, okay, looking at the absolute value, not the minus sign. Looking at the absolute value of the standardized beta, we can tell which variable is most influencing. So now if you look at the beta, you cannot tell. These are all 239, 384. So like that. By looking at unstandardized beta, you cannot tell which variable is influencing more. But when you look at the standardized beta, absolute value, right? Absolute value means 0.235. Don't ignore the minus. So now when the standardized beta is more, 0.832, which means the influence of GDP on gold price is more. So first point, the standardized beta we are getting when the values are standardized, that is the point number one. Point number two, the standardized beta meaning, okay, the use of standardized beta to find out which variable is influencing. When the standardized beta is more, which means influence of that variable is more. Simple logic, simple over. Right. So the purpose of standard deviation, the standardized is to find out the which is having more. Right. So now what is the interpretation for beta? Now regular beta is when there is a 1 unit increase in X, what is the unit increase in Y? Here the interpretation is the interpretation is not that one. Okay, we have to write a little different. Standardized. Okay, so now see here. My standardized beta is 0.580. How to write? When there is a 1 unit standard deviation change in Y. Since here it is plus, let us write when 1 unit standard deviation increase in level of satisfaction, that is the independent variable, will result in 0.580 standard deviation increase in level of commitment. So 1 unit standard deviation change in X. What is the unit standard deviation change in Y? So my X is in the satisfaction, Y is commitment. So when there is a 1 unit standard deviation increase, because it is positive. Okay, when there is a 1 unit standard deviation increase in the level of satisfaction, will result in 0.58 standard deviation increase in the level of commitment. Clear? There are 3 points I am telling. So standardized beta we are getting when the values are standardized. When you run a regression, you will get beta. That beta is a standardized beta. That is point number one. Point number two, purpose of standardized beta is to find out whenever there is a multiple regression, we can find out which variable. So the beta is influence, but which is having more influence, that depends upon the standardized beta. Point number three, how to write interpretation for standardized beta. So with this, we are completing the regression. Now Do you have any doubt? யாருக்காவது டவுட் இருக்கா? ஹலோ ஹலோ.
No, sir.
Okay. So now we will break for 5 minutes. Okay. So after that break, we will. Madam, Meghala Devi, madam. மேடம் இருக்காங்களா இல்லையா? யார் இருக்கிறது? ஜெய் ஸ்ரீராம் யாராவது இருக்காங்களா? ஜெய் ஸ்ரீராம் மேடம். நான் பிடிக்கிறேன். யார்? காசிலிங்கம் 2 இருக்கு. ஜெய் ஸ்ரீராம்னு ஒன்று வச்சிருக்காங்க, பட் எங்கேயோ போயிட்டாங்க. இன்னொன்று 2 மீட்டிங் போஸ்ட் 3, அவங்களே 3 பேர் இருக்காங்க. Okay. So we will break for 5 minutes, then we will assemble. Hello?
Okay, sir.
Okay, sir.
Hello. Hello. Hello.
Hello, sir.
Sri Jyotsna. Very good, madam. How are you, madam?
Yes. Fine,
Are you
thank you, sir.
Are you understanding, madam? Sri Jo, madam?
Sir, regression and all, because I know the basics, I'm able to work out. But the correlation that you are taking on, I need some more time to go through in depth, sir.
Which one? Correlation.
Hmm.
Where correlation? I didn't tell correlation. No, I didn't tell where I say I taught correlation now. Huh? I never taught correlation, madam.
One
Yes.
second, sir. I'm noting down. I have noted down.
I'm teaching only regression, madam. I'm not teaching any correlation.
Okay, okay. No, sir. Sorry. Right.
Okay. So now, see, if you are not understanding any, let me tell you very, very clearly. If you feel, okay, sir, we will go to night, we will learn, you will not learn.
That's
You
true,
learn
sir.
now itself. You learn now itself. Note down now itself. You try to tell now itself. Okay, it is not the future. I'm teaching many years. You are not learning in the class, you will not learn. You will not find time, number one. Number two, so you will not, intricacies you will not learn. That is why you have to learn when the teacher is teaching. Very good. So now,
I agree with you, sir. I agree with you.
okay. Now, any doubt? Anything? Okay, I'm going to use sum now. Okay, same thing. I'm going to run with the sum.
Okay, sir.
Okay, so now one more. Let me do the standardized beta. Okay, again. Okay, so with the second example. Okay, so now let me take the second example. This one, right? Now, how to get standardized value? Somebody please tell how to get standardized value. Yeah, tell. How to get standardized value? Hello? How to get standardized value? Hello? Hello, how to get standardized value? I will ask some madam, right? Sindhu Ravindran? Sindhu Ravindran? Sindhu Ravindran? Sandhya madam? Sandhya? Where are they? They are there or not?
Sir, are you asking about standardized beta, sir?
No. When I am calling you, please respond, madam. That is the first request.
Okay.
Now, this is now I want to get a standardized value here. How to get standardized value? Variable. How to get? So, which means you have not listened. Hello?
Sir, actually, we need to go to analyze, descriptive,
Analyze.
descriptive.
Descriptive.
Statistics.
Yeah. Then we have to go. We have to select the variable. That is total income, total savings.
Wait.
Descriptive statistics and then descriptives.
Wait. Descriptive statistics.
Descriptives.
Descriptives.
We have to select the variable.
We have to select the variable and
then we have to click that save standardized values as variable.
Save
standardized values as variable.
Variable. Very good. Now we will get. Now we got it.
2 columns.
Got it. Right. So now let me run again. Let me run with the original variable, and I will run with this variable. First, let me run regression with the original variable because we have run. Okay. So, but again I will do right. Okay. So this one let me run. Okay. Again. So now my beta is 0.161. My standardized beta is 0.404. Right, my beta is 0.161. What is my standardized beta? 0.404. Right. What is my standardized beta?
0.404.
Okay, very good. You please tell. Okay. Now. Okay, regression, linear, right? So now I am taking this two, right? Is that total saving here? Okay. Now my beta itself will be 0.404. Right. Very good. So now what is the use of standardized beta? Anybody, what is the use of standardized beta? What is the use of standardized beta? Hello, madam, solunga. Yeah, solunga, madam. எங்க பிட் போட்டிருக்கீங்க? இல்ல சார், அந்த ப்ரோகிராம் போயிட்டு இருக்குல சார், நடுவுல. எங்க போயிட்டு இருக்கு? சார், நான் வேகமா பேசுறேன் சார். சொல்லுங்க மேடம், தெரியுது, சொல்லுங்க. ஓகே ஓகே சார். என்னல சார், உங்களுக்கு டெஸ்ட் அப்படியே நடத்திடலாமா சார்? क्वेश्चंस கேட்டா மாதிரி ஆன்சரே பண்ண மாட்டேங்கிறாங்க. இல்ல பரவாயில்ல, நீங்க கவலைப்படாதீங்க மேடம், நான் பாத்துக்கிறேன். அவங்க ரெஸ்பாண்ட் பண்ணட்டும், இல்லன்னா ஒன்றும் யூஸ் இல்லை மேடம், நான் பாத்துக்கிறேன். ஐ வில் டேக் கேர். ஓகே, தேங்க்யூ. Okay, so now somebody please tell me what is the use of standardized beta. Somebody please tell.
To find out which variable influence more.
Very good, good madam, very good. So when there are many variables, all right, so we will tell this variable influencing, this variable influencing, this variable influencing, all variable influencing, variable which is influencing, to find out which variable is influencing more, which variable is influencing less. That we can find out with the help of the standardized beta. That is the use. Okay, very good. Okay, so now what is the interpretation for this standardized beta now? Now 0.404. What is the inference for standardized beta? Inference. How do you write inference? Somebody please tell.
1 unit standard deviation increase in level of
here income.
Income.
1 unit standard deviation increase in income.
Will result in 0.404 standard deviation increase in savings.
Okay, very good. That's all right. Who has given this answer? Nice, madam. Who has given this answer?
Thank you, sir. This is Tilaka here, sir.
Within kitchen.
Tilaka.
Tilaka இது?
ஆமாங்க சார்.
அது உங்க பையனா?
ஆமாங்க சார்.
அவனுக்கு என்ன இவ்வளவு பட்டையை போட்டு விட்டீங்க பாவம்? சரி, வெரி குட். திலகா மேடம், நல்ல ரெஸ்பான்ஸ். வெரி குட், ரைட், வெரி குட். இவ்வளவுதான். ஓகே, திஸ் யூ நோ, which means you know same, nothing more than that. That's all. Now, right, now I'm going to perform this. Okay, so let us have See, please note down the earlier result for commitment and savings. Right, commitment and the saving result. Okay, so now note down the result. This result, you know. So my, okay, so A value is, okay, I'm going to perform with same thing. My my A value is, that is a constant value, is 1.578. This my unstandardized beta is 0.592. My standardized beta is 0.580. Right? So my R square is, what is my R square? 0.336, right? So I hope you, these are all you noted down. So now I'm going to perform with the sum, right? I will perform with the sum. Okay, so now if I open, so when I open sum, I should get like this. I'm having like this. Okay, so empty screen. Okay, so now we have some menus. Okay, so this is the AMOS graphics. This is AMOS graphics meant for drawing the diagram. Right? So what I'm going to do is same thing, whatever I run with whatever I was running with the regression, I'm going to run here. Right, first, see what is my this one? Satisfaction influence the commitment or not. Okay, that is my objective. So I have one variable satisfaction, another I have variable commitment. Right. So now I'm going read this one. Read. I have something, right? Please read. Please read. Please read what it is.
Draw observed variables.
Right. Whenever you want to draw observed variable, you have to use this one. To draw observed variable, I got values. I can see, right? 3, 4, something. I got values, right? So see here. Okay. So now I got values for commitment. Now I got values for happiness. So whenever you have values for that variable, that is called observed. We can see the values. That is called observed variable. So for variable, if you have values, that is called observed variable, right? So now, so I have to. Okay. So now I'm going to take this one because my variables are observed. So let me draw, right? I'm drawing, holding the mouse like this, left it. So then one more I want. Okay, I put like this, that's all. So now this is for, okay, deselect, right? Deselected. So this is to keep satisfaction, this is to keep commitment. So now single arrow. Now what is this one? Now you have to read. Please read what is this one. Draw
Paths.
So draw path, single-headed arrow. All right. So now it is called a single-headed arrow. Single-headed, you can see single-headed arrow. Okay, single-headed arrow is used to draw influence path. Right. This is the path. Single-headed arrow, right? So now if you look at this diagram, this box is influencing this box. That is the meaning. When I put double-sided, it is a relationship. Single-headed influence, double-sided relation, right? So now that is over. Now, see, now to capture, see, dependent variable, we are capturing, we are trying to find, find out only 33.6%. Remaining is error, residual. So to capture the residual, I have to keep this error. Okay. So what is the error? Add, read, add. Somebody please read. Okay. So probably that. Read, madam.
Add. Sir, it is not showing.
வராது வா கொஞ்சம் add a unique
add a
variable.
unique variable to an existing variable.
Right. So click it. Right. Click it. You have to select it. Select it and you place it here. Right. Place it here. Done. Right. Done. Right. Okay. That is okay. So now I have okay. Now my drawing is over. So first step you have to draw. First step you have to draw. To draw we have to use all these things, right? Okay, very good. So we will try to learn all one by one, right? So we have learned one this one, two this one, and three things we have learned now. So now we are in the AMOS graphics screen. Data is in SPSS, right? Now we have to bring that is in some file, this is in some file, right? We have to bring that, we have to link these two, right? So directly if it is the SPSS and AMOS, both are from same company, so we can use straight away. We need not import. If it is some other database, then we have to import, right? Now we need not import, straight away we can link. So to link here read what it is. Somebody please read.
Select data files.
To select a data file, right? Now I am clicking, right? Here I am going, right? File name, I have to select where it is. Selecting, right? File name. Symbol sum, employee branding, right? That is selected. Then okay, it has come, right? File, it has come. Okay, file, it has come. Number 100 sample size. Okay. Done. Now linked. Now here this box should take some variable, this box should take some variable, right? So that mapping, that is called, this is linking, this is mapping the diagram with the variable, right? So this I can for this one, if you click the left hand side and I can move like this, right? So this is my independent variable, this is my dependent variable. This variable influence, right? Happiness, let me take happiness, let me put here, and commitment, let me put here, right? Done. So now here what probably you will make mistake is, see for example, you select it here, you will place it somewhere here, then it will come like this. Then you can use this scissor to erase the object, erase object, right? So erase it, you can erase it, right? So whenever, so what you have to do is you have to select, track it, the color will change, then you put it there. So this variable is name unnamed, right? This variable, right click, object property, right click, object property. That is the error. So let me put E1. Okay. Now, okay. So database linking, object mapping, and all naming, everything over. Okay. Now I have to analyze property. Analyze property. This one. Analyze property. Read. Read.
Analysis property. Analyze property.
Yeah,
analysis property.
Now here I want estimate means and intercept, but you need not click this one. Don't click this one. But now I want to show the intercept value, A value. A is otherwise called intercept. Okay, so that is why I'm clicking this one. Then in the output, this is in the estimation. Estimate means and intercept. Output standardized values, right? Because I want to have standardized beta and I want to have R squared multiple correlation. I want to show the R square value of 0.336 and the standardized estimate of 0.580. All these things I want to show. That is why I'm clicking in the output. Output, I want to see this output. Done. So now execution, right? Execution, before execution, this is okay. Whenever you have input, you are seeing the input path diagram. Here now it is once executed, that will come. Okay, so that will come right now. Now this calculate estimates. Read calculate estimates. Yes or no?
Yes, sir.
Yes, right. Estimates.
Let me click that. Then this should come, which means it is going to execute it. Okay, so it is asking you to save. Okay, if there is any problem, this will not come. Okay, so let me save it in the desktop. Desktop. Okay, so yesterday also I have S1. Let me put S2. I have S1 already. Okay, now it is running, executed. Now you can see this one. Now view the output path. This is input path, this is output path. Now result is ready. Now if you click this one, figures will come. This is what it is. That's all. This is the execution, right? This is the path diagram, path analysis. Okay, structural model, all. Right? Very good. Now you can see, okay, you can see some of the values, right? If you click, if you want to show the unstandardized, you can click here. Values will change. For standardized, the error value, this error value, variance value, all will not come. See here. So this is the mean value, 3.64. This is the error variance value. This is the error variance. All will not come. This is the intercept value. Intercept value, right? Okay. So now we will see one by one, right? Okay. So now here, okay, this one. Now let us go to the output. I want to see the output, right? To see the output here itself, here itself you can see the output. But I want to see the text output in a textual form, for which I will go this view text. Read view text, right? Let me read. Okay, let me click. So when you are clicked, it will go within this one. So here, click it. It is minimized. So maximize. It will come here. Now estimates. I'm clicking this. Estimates. Now if you click here, you can type it. Now, okay. So now you can, okay, whatever we have stated in regression only we are going to get. See here, p-value is first p-value. Here the only difference is there we will call it as significant value. Here we will call it as p-value. P-value means probability value. P-value means probability value. What is p-value?
Probability value, sir.
Okay, probability value. Otherwise, probability of committing type 1 error. Statistically, probability means probability of committing type 1 error. You can write. Probability of committing type 1 error. Okay, so this is 0.000. So what you mean by star? It means 0, right? 0, right? So when there are 3 zeros, then it will give 3 stars. More than 3 zero also 3 star only it will show. If there is some values, it will show 0.02 like that. Okay. Now it is 3 star, which means 0.000. Right. Now how will you interpret? Somebody tell. This is nothing but significant value. Yeah, please tell.
Significant value is less than 0.05, then reject the null hypothesis.
Very good. Okay. Which means
There is an influence of commitment on
there is influence of savings on
savings on it.
satisfaction on commitment. Yes or no?
Commitment.
Yeah. Now look at this one. Look at this one. You can see here. Happiness is the independent variable. See here arrow. Happiness is influencing the commitment. So now, okay, the Tilaga madam is telling right answer. So now p value is 0.000, which is less than 0.05, which means happiness is influencing the commitment. Right. Now, okay, so p value is significant value. Whatever you write for significant value, you have to write for p value. Next, here we have a CR value. CR value means critical ratio. CR value means critical ratio. Now here, okay, so all t value in AMOS it calls as critical ratio. All t value it is called as critical ratio in AMOS. So it is t value. Now what is the t value?
7.075.
So now how will you write? T value is
Greater than, more than 1.96.
1.96, which means
there is an influence.
There is an influence. That's all. So now this is okay. Okay, critical ratio is that is nothing but t value. Now, what is the beta value? What is the beta value? So the estimate is otherwise called beta value. Now,
0.580.
No. That is the standardized beta. Here
0.592, sir.
592. See, you have not noted down this one. That is why I see. I have already noted down many times.
0.592.
Before coming here itself, I have told you, right? So you should note it down. Note it down means you should note it down. Then you will not see. You think we remember, you will not remember. See here, this is the standardized. See here, unstandardized beta is 0.592, standardized beta is 0.580. All these things you should note it down. The R square value is 0.336. All these things you should. The intercept value is, what is the intercept value? 1.578. That all note it down. So now this estimate, this is a regression weight. This is the unstandardized. Regression weight is unstandardized. So my unstandardized estimate, that is the beta estimate. So this is the beta estimate. Beta estimate is 0.592. So my standardized regression weight is the standardized beta. What is my standardized beta? What is my standardized?
0.50, sir.
0.50, sir.
Right. So what is the interpretation? When there is a 1 unit increase in standard deviation increase in happiness will result in 0.580 standard deviation increase in commitment. Right. So now intercept value, what is the intercept value? A value 1.578. Yes or no?
Yes, sir.
Yes or no? Okay.
Yes, 1.57.
My what is my squared multiple correlation? R square. Okay.
0.336, sir.
Sir.
Okay. Now. Okay. Now. Okay. So now I think you will understand the path model or structural model is similar to regression. Is it okay?
Yes, sir. Yes, sir.
So now there is a question. What question? Sir, when this is similar to regression, then what is the necessity for this one, sir? We can as well use regression, then what we have to use? Okay, so now it is having some more purposes, but all interpretation is regression. Whatever the model, whatever we do, okay, we'll get to the same result only. Yeah, okay, so we'll get the same result, right? So then what is the purpose? Okay, I will tell. I'm going to tell. Okay, it is having some specific purpose. So what cannot be performed regression can be performed with this one. Okay, so that we will see. Now, so all data are given to you, right? So in the evening, you please perform and try to write again. Okay. So whether even if you spend 1 hour more, no problem, perform and write it. Software is given, right? Even if you require SPSS software, I'm ready to send. Because you are attending 3 days. After attending 3 days, if you do not know the simple thing, then what is the use of it? So now what you see now? What you see now?
Question.
Yeah, okay, questionnaire, right. Okay. Now, what is the difference between earlier questionnaire and this questionnaire? Earlier, I have shown a questionnaire only 4 questions. Now, what is the difference between this questionnaire and that questionnaire? What is the difference?
Single question was there.
What is single questionnaire?
Here in a group, particular interrelation.
No. In the questionnaire, what is it? You have shown earlier one question. Now I am showing
The
1%.
previous was a 5 scale rating. Here it is like a degree of comparison.
Okay. So now here also 5-point scale only. Here
Sir,
also
more
5.
number of statements.
See now
அந்த
Technology
single
is
statement இருந்துச்சு சார்.
here, see, in constructing questionnaire, in the designing of the questionnaire might be, see, in the every bottom you can put 5-point scale, or here you can put this one, or otherwise you can put one table, otherwise one column alone you can ask them to give rating, like that. Any design you can do. So now that is not the difference. What else somebody they are telling?
technology is one variable under more than one statement, sir.
So now here the difference is there. Each is measuring one thing, right? Happiness, only one statement. Commitment, only one statement. Okay. Here, technology is one variable. Okay. Now one variable for which, under which we have 5 items. It is not single item. It is measured with the 5 items. Okay. Now, if the questionnaire is like this, then we call the technology as a one factor, one domain, construct, or dimension. Many words. We can tell factor, one domain, one dimension, one construct. We can use all these words. Now here the bottom, these are all the 5, we call it as items or statements or indicators. Normally we call it as indicators and items, statements, anything can come. Now we want to know the level of technology available in the banks. That is the idea. We want to know level of technology available in the banks. But we are not asking what is the level of technology straight away. Are you happy with the technology? We are not asking like that. Rather, in the technology itself, we feel there are core banking facility, ATM facility, net banking facility, phone banking facility, like that. This is of course old questionnaire conducted. Okay, so probably 2007 or 8. So many years gone. So now technology is one factor, one construct, which is measured through 5 items. So we do not have directly value for technology. That is why we call technology as a latent variable, not observed variable. But my bank offer efficient core banking facility for which the people might have ticked, value will be there. That is the observed variable. So this A, B, C, D are observed variable for which people might have given the answer. So that we might have entered. So that is the observed variable. This is a latent variable. So now we are using the construct in the questionnaire. We are using construct in the questionnaire. Okay, that is the difference here. So in this questionnaire, constructs are used. Right. Okay. Now, see, we will not be trying to find out relationship between the items. That we are not worried. We want to know only the technology. We want to know only the personnel. Right. So we do not want this one. We want only technology. That is our main focus. So now I want to find out whether, let me look at this one. Now I want to find out whether technology influence the convenience. Technology influence the convenience. Problem solving. But the technology is a construct. Convenience is a construct. Now I want to find out the influence of one construct, not one variable, okay, not one item. It is the influence of one construct on the another. Okay, so that is my objective that I'm going to draw now. Okay, so now if you want to remove these values, if you click this one, okay, input path, all values will go. Okay, so whenever you want to make changes, okay, click this input diagram and right. So now, okay, so let me go new. Okay, now I got new. So now, okay, you have to draw everything inside this white screen. That is the drawing area. We cannot put anything outside. We have to put inside. School of Law. Sir, vanakkam. சொல்லுங்க என்ன ரிசல்ட்டுக்கா எதுக்கு? ஈவினிங் ஃபுல்லா ஃப்ரீ தான். இந்த ஈவினிங் என்னாலும் ஃப்ரீ தான். எனி டைம் ஃப்ரீ. எனி டைம் ஃப்ரீ சார். நீங்க சொல்லிட்டு சொல்லுங்க ஃப்ரீ சார். 2:30 3 மணிக்கு வைங்க. ஓகே, தேங்க்யூ சார். So now I'm going to draw. Right, very good. Now my purpose, one construct influence the other construct. Right. So now how to draw? This is the observed variable that we have used. Whenever you want to use latent variable, this circle, right? See, for example, in PhDs, whenever you use the construct latent variable, see, even in the conceptual model, you put like this, right? So whenever observed variable rectangle, this variable circle use, right? Some people they are using all, we are not finding fault, but it is better. Now I'm going to use this one. Draw latent variable and add indicator to a latent variable. Okay, let me see. Draw latent variable, add indicator, right? So you want to have latent variable, you want to have indicator, that we want. So now you click here, it will come like this, put it, right? So now I want to have 5, right? Both 5, 1, click 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. Done. Right. See, whenever you want to increase this drawing area, view, right? View, interface property, page layout. This is a portrait letter. You put landscape letter. So it will change, right? So now I have a big size. Now, so I want to draw so this PPT also already given to you. Okay, I want to draw like this. Right? Okay. So that is my idea, right? Influence of technology on convenience. Okay. So I have to rotate. So okay, before rotating, okay, so I want to rotate the entire object. I want to rotate the entire object. So use this symmetry, preserve symmetry. Right, you got to write it down, preserve symmetry, right? Preserve symmetry. Then preserve symmetry, then rotation. Here use this rotation. So use this rotation. Rotate. See here how I am rotating. So this, right? Rotation. Rotation over. Right. Rotation over. Now this is away from the box. So I have to move, right? For moving, I am using for rotation, I am using this rotation. Moving, move object, lorry. Then not. Okay. Okay. Now I have to draw the influence arrow. Influence arrow, this one-sided arrow. Okay. So this is 10. This is also over. Then okay, this error, for all dependent variable we should put error. All dependent variable we should put error, right? Okay, the error, right? Arrow ending. How to call it a dependent? How here this is independent variable. This is my dependent. Otherwise, wherever the arrow ends, we need to put the error. So now error, right? Click it, error. Done. So all drawing over. Now data linking. Where I have to go? Where I have to go for data linking? Please tell where I have to go.
Select data files.
Data file, sir.
யார் இது ஒரு ஆள் நல்ல ஆன்சர் சொல்றாங்க. யார் இது? திலகா மேடமா?
சார் நான் சொன்னேங்க சார், இன்னொருத்தவங்க சொன்னாங்க சார்.
யார்? வெரி குட் வெரி குட் வெரி குட் வெரி குட். ஓகே, நான் ஸ்க்ரீன்ல இருக்கிறதுனால எனக்கு தெரியாது மேடம். ஓகே, ஸோ அதனால நீங்க யாருன்னு சொன்னா தான் தெரியும். இப்போ வெரி குட். Select the data. Okay, select the data. Okay, file name. Click the file name. So this data is also I have given to you. Don't think we will do tomorrow. Tonight itself we have to do. Tomorrow I will ask how many people you have done. Bang with 2 constructs. Bang with 2 constructs. Friend construct. And a questionnaire bang with 2. Say okay. So 350 data. This is again collected by one student. Okay. So when I was in St. Joseph College, a student, he has done many analysis, right? He is the first gentleman. He has put 2008 efficiency analysis by using DEA. Then he has done efficiency. What is the title? He has done 3 things. This is for
performance efficiency.
He has done solvency also.
Solvency measurement.
Solvency, right? And 3 things: performance for this one, efficiency, and solvency. Okay, for which he has used the secondary data. So he got a 400 out of 400. That boy. Okay, so data linking over. As soon as data linking is over, next mapping. Right here, list variable in the data set. Read List variable in the data set. List variable in this data set. So it will list out the variables, right? Okay. So let me place one by one. So first technology. Okay, I'm taking technology. See here, I'm carrying this box, red rectangle box only. I have to put. So that is the observe variable, right? See here, red is coming. I'm placing. Red is coming. I'm placing. Done. Sir, இதில் பாருங்க already we have two variables that I will show later. Huh? But here, one thing you need to know. Here, what is this, sir? For which? Right click, object property. Here, this label is coming. I do not want to have this labels. Remove it. Then labels will go. Only name will appear. Otherwise, okay, doing one by one, it will take lot of time because here we have a simple model, right? But in practical this thing, you will be having a very big models. So it will be very difficult. So we will go to plug. We will go to view, interface property, view, interface property, miscellaneous, then display variable labels. That is click, remove it, apply it, it will go. Done. Done. So now you want to make it little big. Okay. So this one, right? See here, what I'm doing. Okay. So now this, right? So this is meant for all design. I told you, no. So now this one, full, or this one. So now that is over. Now here, this variable automatically I can put this variable. This is our own Latin variable. Circle, Latin variable. All circle or Latin variable. So, but this circle, let me give my own name because this is my own variable. So here, whenever before naming, same name already should not be there any of the variable in the data set. Now see here. Here we have data set. Already some variable we have DCHCON. Already we have. So which means these names, all names I should not use. So now let me give. Already DCH I have. So let me put BCHNO technology. Not here. Name. Name. Techno. Okay, so now it is appearing. Now here already we have CON. Let me put CONV convenience. Okay, now it is over. Now this variable should be named. Let me name. Okay, so let me name this one. Right click, object property, E1. E1, error 1, variable name. So like that. Okay, second one I have to put E2 like this. So it will take lot of time. So what I will do is plug in name unobserved variable. Name unobserved. That is circle. Wherever there is a circle, it will name. See, for example, if you have already not given name, it will give F1, F2 like this. all naming over. Okay, so drawing, linking, mapping, all naming over. Analyze property. Okay, so only we will have standardized. Others let us not show. Standardized. Okay, done. Now estimate, right? Calculate estimate. Programming, right? So let me put S3. Done. So if you click this, you will get the output. It is there. So now, okay, so now view text, estimates here. My beta value is, okay, so my objective is to find out whether technology influence convenience, right? So somebody please interpret. Objective is to find out technology influence convenience. Somebody please interpret. Yes.
P-value is less than 0.05, sir.
First you tell the p-value, madam. P-value is 0.00. Yeah.
Which is less than 0.005, sir.
0.005, 0.05, 5%.
0.05, which means that there is a significant, influence on technology on the convenience. Sir.
Yeah, very good. So which means there is a influence. Otherwise you can tell significant influence. That is nothing wrong. You can simply say influence, or you can say there is a significant influence. Right? So critical ratio value is 5.974, which is
above 1.96.
So there is a influence.
Influence.
What is the beta value? Standardized beta value?
0.253, sir.
0.253. So that is my standardized beta estimate. What unstandardized? Unstandardized. Okay. What is standardized beta?
0.363,
sir.
Yeah, 360. Very good. So now you know the meaning for the beta unstandardized beta and the standardized beta. Clear?
Yes,
okay.
Yes,
So now, so same thing is like regression. Okay. So now tomorrow we will see some more thing, right? We will see we will draw same thing. Now I have to tell. Okay. Tomorrow I will tell. Okay. So why this one? Why this one? So why this AMOS? See, whenever we use AMOS, we have to whenever we have a construct. The point is, whenever we have a construct like this in the questionnaire, to find out the influence of one construct on the other construct, you have to use only this sum. You cannot use regression. The point is influence, but we have construct. Right, this kind of diagram or this kind of this thing not possible in regression. In regression, we have to use only the observed variable. Latent variable we cannot use. Right. So now, okay. So remaining this we will see in the next class. Madam, render panna madam.
Yes sir, yes sir. Time up sir.
Yaru.
Megla ma'am pesren sir.
Right, very good. Okay, so time
I am listening to you. Yes.
Okay, very good. Okay, so okay, so we are completed. Tomorrow 10 o'clock we will meet. எல்லாருக்கும் புரியுதா? புரியலையா?
சார்.
புரியுதுங்க சார்.
எஸ் சார், புரியுது சார்.
அப்ப முத்து ஞானேஸ்வரி மேடம் இப்பதான் வர்றாப்புல லைன்ல.
சார் அப்பதான் நோ சார், அப்பப்ப பேசதான் சார் சொல்றேன்.
அப்பப்பா பேசுறீங்களா? ஓகே, வெரி குட். ஸோ பேசிக்கிட்டே இருங்க, பேசினா தான் சரியா வரும். இல்லாட்டா அந்த வார்த்தை வந்து உங்களுக்கு வராதுங்க.
ஓகே சார்.
வார்த்தை தப்பான வார்த்தை பேசிடுவோம், தப்பான வார்த்தை எழுதிடுவோம். அதுக்கு ஒன்னனுக்கும் வேற அர்த்தம் இருக்கு ஒன்னனுக்கும். இப்போ ஃபார் எக்ஸாம்பிள் இன்ஃப்ளூயன்ஸ்னு சொல்றது வேற, ரிலேஷன்ங்கிறது வேற. ரிலேஷனும் ஒரே மாதிரி தான் இருக்கும். ரிலேஷன்னா ஆர் வேல்யூ, இன்ஃப்ளூயன்ஸ்னா ஆர் ஸ்கொயர் வேல்யூ வேற லைட்டா. ஓகே, ஒன்னனுக்கு லைட்டா டிஃப்ரெண்ட்.
ஓகே சார்.
ஆமா, அதனால ஓகே, சிக்னிஃபிகன்ட் இன்ஃப்ளூயன்ஸ் சொல்லலாம், சிக்னிஃபிகன்ட் இன்ஃப்ளூயன்ஸ் ஒன்னா, நத்திங் ராங். ஓகே, ஸோ பட் வெவ்வேறு பேசியிருக்கு. அதுக்காக நீங்க பேசுறீங்கன்னா தான் கரெக்டா வரும். சரி, ஓகே. ஸோ வில் மீட் டுமாரோ.
தேங்க்யூ சார்.
Thank you,
தேங்க்யூ
sir. Thank you, sir.
தேங்க்யூ சார். நாளைக்கு பார்க்கலாங்க சார்.
நாளைக்கு பார்க்கலாம். நாளைக்கு.
தேங்க்யூ சார்.
Participants, the feedback link will be shared in the chat box. Your left ஆகுறேன்.
Thank you all. We will resume the session by tomorrow, the day 3, some analysis using AMOS. Thank you, participants.